Hey everybody, it's Mrs. C, and I'm coming to you today with a little video on adding and subtracting polynomials. And these, hello world, let me introduce you to polynomials. I have this polynomial here, and I have this polynomial here. And if we were to classify them or name them, we would be able to say that this, let me just go back here, this polynomial right here is a three-term, right? So it has three terms. Let me see if I can get my color straight here. Give me 1 second. Okay, I think I'm good here now. I have three terms on this first one, this one, and this one. And, you know, what makes a term is any variable and number combination separated by these little babies right here, pluses and minus signs. So in this case, I have three separate terms separated by pluses or minus signs, and that's what we call a trinomial. Then we can classify it by its degree, and because the highest degree, meaning the highest exponent, this little guy here, is a 5, we would call that a fifth degree trinomial or a quintic trinomial. Over here, do we have the same thing? Yeah, we have another quintic three-termed polynomial. So we have another quintic trinomial. So that's just, nobody really asked us, right, to classify them. But hey, the more exposure we get, the better. So here we're being asked to add or subtract, combine two trinomials or two polynomials. And how do we do that is what this video is about. How do we combine polynomials when the operation or the relationship between them is adding and subtracting? So if you see right here, I'll show you how I know it's adding and subtracting. I've got a minus sign in between them. If it had been no minus sign, can we make it a multiplication relationship? I sure can. I would just, well, maybe that just takes away too much. I can just remove the minus sign. That would make the parentheses touch to it, you know, in essence. They're not really touching, but there's nothing separating them, and therefore the relationship would be multiplication. But in this case, our relationship is subtraction. And so really easy, guys. I mean, it's not going to get too much more straightforward than this. It's pretty easy to combine polys. It's the same as combining anything when we learned how to combine and simplify expressions. The only kicker here is that this is a subtraction sign, and we don't subtract in algebra. We always add the opposite. What I mean by that, a lot of you have seen me do this, is we have to distribute the negative that is outside of that parentheses. It's saying to subtract all of those terms, and in essence, in algebra, that means to add the opposite. So what do? I just take all of those terms and change their signs. I don't spend too much time on this. I just take my handy-dandy pen and I say, change u to a positive, change u to a negative, and change u to a negative. And hopefully, don't forget that when you're combining. So if you would like to, I'll just rewrite it to make it a little bit prettier, but all these exponents, I try not to rewrite. Do you see why I don't want to rewrite that? We're not going to rewrite it. Too hard to rewrite. So what I have now is I have a quantity of these beautiful terms on the left, and they're going to be added to the terms on the right. So this is pretty straightforward. Let me show you what I like to do when I first start out. I like to do a little color coding, because the rules in algebra are you can only combine exactly alike terms. So here's a v to the fifth, and I can combine that to that 12v to the fifth. Let me do another little color here. Here's a v cubed, and where's my other? That's my v cubed. You can't see it. It's kind of hiding underneath that new minus sign. And then I'll do another quick color, and there's my v squared, and there's my v squared. So the rules of adding and subtracting are very specific in algebra. You can only combine exactly alike terms. So in this case, I can combine my pink 3v to the fifth with my 12v to the fifth. And I will have to write this whether I like to or not. I can combine my green 8v to the third with my 4v to the third, and it's a minus. See, you don't want to forget those signs. And then I can combine my 10v squared with my 14v squared. Watch your sign. I won't forget. It's a minus. So now I've taken all of this and I've just moved it underneath the terms that I already have. So I'm done with this, guys. I don't have to worry unless I wanted to keep it, to check. But for right now, I'd just like you to understand that that's all gone. I've rewritten it so that I can combine vertically. And now because I distributed the subtraction sign, I now have an addition relationship, and I just go ahead and I combine. So I'm going to combine my v fifths. 12v to the fifth plus 3v to the fifth is 15v to the fifth. You don't do anything to the exponents. You just combine them. Let's do it again. 8v cubed minus 4v cubed is subtract sign of the higher number, 4v cubed. Don't do anything to your exponents or your variables except to keep them. And then lastly, we have a negative 10v squared minus 14v squared. That's same sign sum, 24v squared. Final answer. We like to ask you sometimes to write it in descending order, which means 5, 3, 2. The numbers go down by degree. So the exponents from highest to least, that's called descending order. Ascending order would be to reverse it and make your exponents go up, square, cube, or to the fifth, depending on what exponents you have. We also like you to classify this. What is this? This is another quintic trinomial. So if you don't know these terms, I have a great video. I think I have 2 different videos on classifying polynomials. And it's really just a matter of memorization. Okay, let's go ahead and, got it. Try another one. You ready? I'm ready. Ba-bum. That's the same one. Okay, that wasn't much fun. Where are you, other problem? There you are, mystery problem. All right, we're going to get rid of the one on the top so that it doesn't distract us. I'm going to move. Can we move this one up a little bit? Sure we can. All right, why don't you give it a little try. Try to move the ones that are on the right over to be underneath the ones that are on the left. I'm going to pause so that I can set it up. You set it up, and then we'll come on back together and we'll take a look at this and see if we can simplify it. Okay, I've got it. First of all, I didn't copy it because I wanted to color code, because we had said, sometimes in the beginning when you do this, a little color coding is helpful. I've seen students draw shapes around the different terms. That gets a little bit cluttered. So just at the beginning, you don't have to do it every time, but notice how many colors do I have? How many distinct colors? I have red, I have yellow, green, and blue. Wow, I didn't really see that coming when I first put the problem down. See, I can combine my reds, and let me just do my little erase here, because I don't really want, that's a really big eraser. I have that set pretty large. Okay. I can combine my reds. I'll bring my negative 5k to the fourth down. Now, you may be saying, wait a minute, you didn't do the distributive thing. No, I'm not, because that's a plus sign. And if I did, a positive times a negative, positive times a negative is negative. So nothing is going to change when this is a positive on the outside. You can certainly do the work, but I'm not going to see any need to do that. So I only do it when it's a negative in the middle of them. So I'm going to bring my negative 5k to the fourth underneath my other red, negative 5k to the 4. I'm going to bring my green 6k cubed, and my negative 8k to the 5th. Oh, I don't have a place for it, negative 8k to the 5th. Where do I put it? Put it anywhere, just don't put it underneath somebody else. How about negative 8k to the 5th? He's supposed to be in front anyway. He's got the highest degree. And what about this this little yellow 3? There's nobody on the right. who's yellow. So nobody combines. A big old, we could say 0. There's nothing. You don't have to put a 0, but it's nice to make it hold the place. Now you double check. Did I copy everything? Did I do the right signs? Well, I don't have a sign there. That might be helpful. All right, it looks pretty good to me. Now we combine. There's nobody above the 8k to the 5th, so we just copy it. We have a k to the 4th and a negative k to the 4th. That's a negative 4k to the 4th. We have a 0 and a negative 3. That's a negative 3. And we have a negative 3 and a positive 6, and they're both k cubes. That's going to give me a positive 3k cubed. Now, if you had been asked to write this in descending order, you would want to swap these two terms. The negative 3 and the negative 3k cubed should be in different positions. So it would be a negative 8k to the 5th minus 4k to the 4th plus 3k cubed minus 3. A nice 4-term poly. I don't have a word for that. I'm sure there's a word out there somewhere, but I don't know. You could Google it. And it's a quintic 4-term polynomial. Wow. All right. Let's see. Do I have any other practice hiding under here? I'm not sure what's hiding under here. Oh, good. All right. Let's try that one. You feeling like you could handle that one? I think you could. All right. You go ahead and do this one. I'm going to do the next one, but I'm not going to color code. So let's see if we can do it without color coding. Go ahead and pause it. Come back to me when you're ready. All right, I said I wasn't going to color code, so let's do it. I'm going to distribute this negative, turning everybody to the opposite sign. Okay, that was multiplying everybody by that negative 1. Now I'm going to bring down or bring around my terms. So I have to combine this 10k with the other k. Here we go. There's the k's. Then I've got to combine my positive 7. That should go right there, don't you think? And I got to combine my 2k squared. It's a positive 2k squared. Nicely. A little squeezed in, but no big deal. 8 and 10 is 18k. 2 and 1 is 3k squared. And a negative 6 and a positive 7 is a 1. In descending order, we would say 3k squared plus 18k plus 1. This is called a second degree trinomial, or what we refer to as a quadratic trinomial. Again, if you don't know what I'm talking about, watch the video on naming polynomials. And that looks like it's the end, unless there's somebody here. Oh, who's that hiding there? What are you doing there? All right, I'm at the bottom of my page, but I think. What do you think? Right about there? I think so. Okay, well, looking at this and you're saying, whoa, what is that, Mrs. C? We didn't do any threes. I mean, look, there's three, not terms, but there's 3 different sets of polys. Just be happy they're all addition. Sorry. Just be happy they're all addition. We don't have to do any subtraction. So we do the same thing. I have a lot of students that say, well, I get the ones where there's just the 2 of them, but when there's 3 of them, I don't understand what to do. You do the same thing you always did. Now, guys, when I move these, I'm not going to move everybody over to this side when I recopy, because I just think it would be neater, maybe less work for me in the end, if I maybe moved these guys here and these guys here and just put everybody in the middle. Sometimes that works well, and since I have all this extra space up on top, I think I'm going to move one on top and one on the bottom and combine them like that. You have the freedom to kind of work with your space as best as you can. So I'm just going to see if this will let me get rid of that line. There, it did. And that up there. And let's go do it. I'm going to move everybody to the middle. So I'm going to try to find a home for negative 9v squared. Oop, right there. Negative, that's a u. Oh, okay. Well, that's a little tricky. Do you see that? That's a u squared. Negative 9v squared. Make your v's look really like v's. Then what shall we do with you, little negative 8u? Well, little negative 8u doesn't have a place to go, does it? So I'm going to write little negative 8u out here. All right, I got both of you guys. You're done. How about you? Negative v squared. I think you're going to find your home right here. And I got you. And a 4uv. Oh, I got a 2uv over here, so let's add you there. 4uv. Square, square. I got a u squared here. I don't know if you can see because the columns. Let me do a different color for columns. You got to learn how to organize your space. I got these guys right there, combining with wiggity wig right there, and then that. These are my adding columns because I have the u's. I'll put it up here above the column. I have u's here. I have uv's here. I have u squareds here. And I have v squareds here. And they're all different. So what I like to do is a little double check to make sure I did really find a home for negative 9v squared right there. And I'm looking. You look too. I did find a place for the negative u right there. And I found the negative v squared, yes, and I found the 4uv. We're good. Now we just have to combine these. Don't lose anybody because this is a big old 0 here. So I'm going to do another color just so that it's a little bit clearer what we're doing. We're going to add the columns, and I believe, if you recall, this little u, this little piggy, this little u is all by itself. There were no other u's, so it's being added to nothing else on top. So we have a negative 8u. Then we have these two guys. Negative 2uv and a 4uv is a 2uv, positive. Then we have the negative 2u that has nobody else squared to be with. And a whole bunch of v squareds, right? We have a 9v squared and a negative, we have a negative 9 and a negative 1. That's a negative 10v squared. And then this little positive 1 brings me back down. These two cancel out to a negative 9v squared. Now the last little step would be to organize them, but I don't ask you to organize them when there is more than one variable. I just say leave it like it is. You can work with your Algebra 2 teachers. Maybe they can talk to you about the proper organization of polynomials that are this complicated. This is a second degree polynomial, and because the highest degree is a 2. And there are 4 terms, so it's a 4-term quadratic polynomial, or yes, I think. There was some little rule where you do something with the 2 little exponents, but that's going to have to be another video. We won't need to in Algebra 1 to classify one that looks like this. Just got to be able to combine them. So that's your final answer. I hope this video was helpful to you. And I hope now that when you go to combine your polys, you realize it's really not that big of a deal. Polys are pretty easy. But I do want to just do a quick, this video again, these problems came from CUDA. See, there's a lot of them. This video, these video problems came from the CUDA website. And I just want to caution you, I'm going to put them all up for you. And you can see the CUDA website for all of the answers. You can check my work. I just want to seriously caution you to not make the mistakes of everybody, anybody who ever does this, does something wrong. What is it? What do these all have in common? The negatives, the subtractions. You forget to distribute that subtraction sign, and your answer's gonna be wrong. So please, whenever there's a minus sign in front of your parenthesis, you got to distribute that minus, or you got to change all the signs that are inside the one that the parenthesis that it's touching. All right, guys, until the next time, I will see you, as always, on the flip side. Later.